All right, I have that it's noon, so I think in order to stay on pace, we're going to get started. So a couple housekeeping items to get us going. This is week 2 of our 5-week webinar, so thank you for joining us once again. We have 3 great speakers lined up for today, Brent, AMINA, and ERIN, and they're going to be talking through some of both our best suggestions for managing these systems, as well as some of the ongoing research work we have about how wide does that crop width zone really need to be, and then what are some options for weed control in these systems, especially during establishment years. So once again, I'm Dan Anderson, happy to host this session. If you have any questions throughout, feel free to type them in the chat box. We will have a moment or two as we switch slides between presenters to try and answer some of those questions, and then some space built in the end to try and answer questions as well. We did release a couple poll questions to sort of understand what your concerns are and opportunities within these systems. So if you would be so kind as to fill those out, we greatly appreciate it. To get us started today, we have Brent Wilson from Corteva Agriscience, and Brent has been helping with quite a few on-farm trials to get these systems up and rolling on some farms, and going to talk through some of his experiences about what he's learned on those farms and some ways that we can try and manage these systems to be effective. So with that, thanks for joining us today, Brent, and the floor is yours.
All right. Thanks, Dan. Good day, everybody. Again, appreciate you joining us to talk about perennial ground covers and how to implement them. First of all, a big shout out to our farmer cooperators. They've been great to work with in really showing their willingness and adaptability to really trying a new and pretty novel system. So many thanks to them. We couldn't move this project forward without their help and assistance. So I'm going to focus in on one specific aspect of perennial ground covers and management, and that's really that crop growth zone. Because if you think about what we're trying to do is, and this is the big mindset shift for a lot of us, is that we're actually trying to grow 2 crops at once. And we want to make sure that our cash crop, our corn and soybeans in this case, thrive while we keep our perennial ground cover alive. And notice that's a difference. We're not trying to grow the most bluegrass we absolutely can in this case, but we are trying to optimize our yield potential in our cash crop. So we need to manage that competition between the two. Now, fortunately, by selecting bluegrass in this case as our perennial ground cover, we do buy ourselves some forgiveness on the time competition aspect, because we know that bluegrass is a cool season perennial. It's going to be most active in its growth, kind of early in the season through June, and then late in the season after the growing season kind of cools off here in the Northern Hemisphere. So obviously in between that time is when our cash crop is going to be most active. June, July, August is when we're going to, produce the bulk of our corn and soybean crop. So bluegrass works as a nice complement in that it's different in its growth pattern. And this graphic on the screen also highlights that the rooting patterns are different. So I get a lot of questions from farmers as well, isn't that bluegrass going to be way too competitive? And it can be, but I think through good management and the kind of the growth habits and taking advantage of how bluegrass grows and compared to corn and soybeans, we actually, definitely can manage this. One of the aspects that we need to think about is maintaining that crop zone. And I've got some slides here from last year, both the good and the bad. If we start off on the left side of the screen, you can see that bluegrass can get very aggressive if we're in a cool season with lots of rain and we don't use our suppression to our fullest extent as far as keeping that bluegrass in check. It can get pretty woolly. And so that center slide really shows the advantage of having a crop growth zone. Hopefully you can see that there's a section there where you can see a bit of strip of brown soil in the middle, and the corn obviously is more robust there, has bigger leaves. Where that bluegrass is kind of encroached in on the crop row, it's obviously struggling a little more. What we're really looking for is that slide demonstrates there on the right, where we have this nice clean band of relatively bare soil, right where the crop is growing, and in between we have a perennial ground cover that is suppressed. It's not looking like your lawn. We don't want it to. We need it to be there and live and provide us those kind of ecosystem services as far as retaining moisture and preventing runoff and cycling nutrients. But it doesn't have to be actively growing mid-season. So that's the slide we're shooting for. So if you kind of get that in your mindset, how do we create that crop zone? And probably what we've seen, the easiest place to start is really with a strip till system, because we can use whatever advantages tillage have, depending on your soil type, with that strip till rig to kind of create that open zone where we're going to place that crop and let it develop and mature without a lot of competition from that perennial ground cover. I like strip till even outside of a perennial ground cover system. I love the way that we can place nutrients, directly under that crop zone into that crop furrow. It, in my mind, creates a very nice seed bed, and it doesn't obviously disturb the whole soil surface. So we get some advantages of reduced tillage, yet still some advantages of a tilled environment where we're placing that seed. The thing to keep in mind is that a strip till machine really is not a plow. It is not going to take out an established sod. Obviously, we're not going to go into a pasture and use a strip till machine to try and create a perennial ground cover. We're going to want to seed that ground cover in between the rows and then keep that crop zone free from bluegrass encroaching in right on top of that row. So the picture on the right kind of shows the start of a season, kind of what we're looking for. Again, this is a very healthy bluegrass stand. If it looked a little more struggling than this, I'd be okay with that. It doesn't need to be quite this thick, but again, it gives you an idea of what we're shooting for as we use a strip till machine to create that crop zone. So you may be asking yourself, okay, strip till may not be my best option due to ground slope or some other, farm constraints. What else could I use if I don't have a strip till rig to create this crop zone? We've had some growers actually use in no-till, create the crop zone by using a chemical band. Usually it's glyphosate, Roundup, that's applied in that 10 to 15-inch band. I've had a grower that did this in the fall. He actually set up his field sprayer with band nozzles, put the boom height at the right level, the right height to get that the right width of the spray band, and it worked actually quite well. Glyphosate in the fall, it translocates into the root systems and limits that growth of that bluegrass, getting ready for that next spring planting. So if that doesn't work, what's our next option? If we can't get it on in the fall or the spring with a field sprayer, obviously we could put on a tank and nozzles on our planter, which obviously great control. We know exactly where that row is going to be, and we can put our band exactly where we need it. Some growers don't particularly like to add any more things to their planter than they already have, so that's a consideration. And then probably the final option that we could think about in using a chemical band to establish a crop zone is using a hooded sprayer. And I had to search a bit to find a picture of a hooded sprayer because I really didn't want to show you Grandpa's version, from the 1980s of a 6-row sprayer with a PVC hood. So they still make hooded sprayers, and then the sharp ones on the line are going to see that this one probably didn't come out of the Midwest since there's 13 rows. So this is one that's being used in specialty crops, but I think it does highlight the point that we do have equipment that is out there that could be adapted using a hooded sprayer that would fit our production systems versus having to kind of build your own if you wanted to go for that option. So those are kind of the two main ways that I see of establishing a crop zone. Just one other, kind of consideration I get a lot of questions from farmers is how do I manage nutrients? Again, if we're in a perennial ground cover with a crop zone where the crop is growing, strip till is a great solution there because it places nutrients right in that row. For nitrogen applications, obviously we can band it with our strip till machine. I've had growers broadcast it with pretty good results. I think it just proves how flexible nitrogen can be when it comes to that corn being able to reach it and take it up and utilize it to produce yield. If I had my preferences and I was side dressing, I've again had growers that side dress, banded it right down the middle of the row, like the picture on the right shows, and still produce 250 bushel corn. But if I had to do this for year after year, I'd probably favor the Y drops, being able to place that side dress application in right with the corn row, and so I don't have to worry about any kind of interference from the cover crop. So in simple terms, there's two methodologies when we think about, maintaining that crop zone. It's either strip till or it's using a chemical band. And it's one of the, in my mind, one of the three keys to keeping perennial ground covers productive. Once we get it established, we need to make sure we get that crop zone going and keep it there. Then obviously the third one, which is for another talk, would be around how do we suppress that ground cover early in the season. So with that, Dan, that's what I have to share. If there's any quick questions or we need to move on, you tell me.
So if you have questions as we switch presenters here, feel free to type them in the chat. But I have one to get us started, Brent. With your experience on farm, what's been the primary concern? Is it too vigorous of grass? And what are some of your best suggestions to manage that?
So the thing, our biggest issue is that bluegrass is very slow to establish. So we tend to have to kind of baby it that first year, and then it can turn into a 900-pound gorilla once it gets established. So you've got to be ready to make the switch between being very careful and how we, what herbicides we use and how rough we are on the first year stand of bluegrass. Once you get into year 2 and beyond, you can beat the heck out of it. We have lots of different options for our typical herbicides programs. We want to be aggressive in keeping it out of the row. So to me, that's a challenge, Dan, is that switch between going from being very cautious and careful to being pretty aggressive at keeping that bluegrass ground cover in check.
Perfect. Thanks, Brent. So if I could get you to stop sharing. Beautiful. And Amina, you're up. So next up, we have Amina. She is a grad student working on this project. And specifically, she has a really innovative experiment trying to understand the distance required for how far does that ground cover have to be between the rows. So I think, Amina, if you click on display settings up there on top, that little arrow on the side, yep. Oh, it should let us swap. Interesting.
Oh,
All right. Do you have a double monitor?
no.
No. I've not seen that one. Yeah, stop sharing and then retry sharing. Try sharing rather than your screen, the Excel or the PowerPoint, and see if it will pop up the whole screen that way.
Is it okay now?
Beautiful. So thanks for joining us, Amina, and we look forward to hearing about your research.
Okay, thank you for having me. Brad also already talked about maintaining the crop zone. And what is the crop zone that we need to maintain? So in my research, we are trying to look at the right cropping zone to plant corn from a perennial ground cover system. So we all know that plants compete with each other in so many various ways, that being below ground competition and above ground competition. But most of the cases, farmers do look at the below ground competition to see whether the nutrient requirement is right and if the water requirement is right. But they don't intend to look at the above ground competition for space and sunlight, which is something we should also look at. Because when you even plant in a monoculture system and you don't even maintain the right distance between the crops, there will be an intra-specific competition between the two crops, which will reduce yield. But in this case, we are actually looking at two species at the same time. So we need to actually look at the distance at which these two crops will not compete with each other so that our cash crop we can have the ecosystem benefit of the perennial ground cover and still get the yield that we want in our cash crop. So in my case, we'll be looking at various distances and how they impact the corn growth and development in the field. So the objective of the study was to determine the area of influence of perennial ground cover on the corn plant, to look at how the corn plant behave. And secondly, to look at the phenotypical changes of the corn plant in the field. How does the corn plant behave when it's closer to the perennial ground cover? And we also wanted to apply a starter nitrogen fertilizer to look whether application of a starter nitrogen fertilizer will actually help the corn plant to compete very well with the perennial ground cover. So the main aim of the study was to actually find the right cropping zone in the perennial ground cover system, where our yield in the corn will be increased, whilst our competition will be minimized in this case. So for us to actually lay down our plot, we envisioned our plot. The map below at the bottom here shows how we envisioned how we wanted to look at our experiment on the field. And with the help of our scientists, we were able to replicate it on the field. So corn was planted at an angle of 14 at different distances from a Kentucky bluegrass. We use Kentucky bluegrass as our perennial ground cover in this system. And our field was actually planted with corn hybrid of different shade avoidance response. And the subplot treatment was an application of a nitrogen starter fertilizer. We wanted to see how the nitrogen fertilizer will actually help the corn plant to compete against the perennial ground cover. So we collected data on the seedling emergence. We wanted to see whether the seedling emergence will be determined, like when the plants are closer to the PGC, will it actually affect the emergence of the corn plant? And we also took distance between each individual corn plants after emergence to see whether each individual corn plant will compete with each other or they will compete with the Kentucky bluegrass. We look at plant height and staging weekly to see the performance of the corn in the field. Stem diameter was also done to look at whether the stems, as they move closer to the PGC, will have a smaller stem diameter. We look at leaf length and weight. We also look at spad readings to check the chlorophyll content of each individual plant. Flowering date was done to see whether the perennial ground cover would delay the flowering date of the plant. And finally, we harvested each individual corn plant. And we wanted to see if how many seeds does each individual plant will produce and the weight of the individual plant. Would the proximity of the PGC affect the weight and the total number and the weight of the seeds? Since the data was robust, because we picked single plant data in the field, we needed to group the data into groups where we'll be able to look it further on the performance of the corn on the field. So we group it as group 1 is plants that are 6 inches from the perennial ground cover. This was done by comparing the corn plants with each other till we got to a point that we could see differences between the corn plant. So group 1 are plants that are 6 inches from the perennial ground cover or below 6 inches from the perennial ground cover. And 2 are plants that are actually above 6 inches but below 30 inches from the perennial ground cover. And finally, our 30 groups are plants that are 30 inches from the perennial ground cover. And these plants also serve as our control plants too. So now let's look at the results. So with the emergence data, this data has been taken for 2 years now. So when you look at our emergence data, within our first year of establishment, as Brad said, the Kentucky bluegrass was still young and you could not see the differences. Although there was a lot of variation in the flowering, but we did not see any differences between the emergence of the corn plant. But when you come to the emergence in the second year, you can clearly see that the plants that are close to the PGC, which is the 6 inches from the PGC, were actually delayed around 3 days. It took 3 days for them to emerge, which is something, if it's not taken care, the yield will actually be reduced. And plant height was also something that we took weekly. And in our first year, we saw hybrid differences and we also saw fertilizer differences, but we did not see the PGC proximity to the having an effect on the plant height. But when you come to the second year, you can clearly see that even the first week that we started collecting data, you can see that plants that are 6 inches from the perennial ground cover had a smaller plant height. And when the plants were flowering, in this case, we can still see that their height were negatively affected by the proximity of the perennial ground cover. And in the stem diameters too, which can be attributed to lodging in the plants if the stem diameters are small. In the first year for data collection, we saw that at the early stage, the stem diameters were small. But as the plant progresses, it was quickly recovered during the flowering stage and we did not see differences. But when you come to the second year, you can clearly see that the stem diameters of the plants are very small when the plants are close to the PGC. You can look at the 6 inches, plants that are 6 inches from the perennial ground cover, which is actually the blue line here. They are very small in stem diameter. And when the plants were at flowering, you can still see that the stem diameters were still low. And when it comes to the spad reading, which is the chlorophyll content of the plants, we saw that in the first year, we did not see differences as usual. But in the second year, the chlorophyll content were actually negatively impacted by the proximity of the perennial ground cover. Plant close to the PGC, as usual, were having a smaller chlorophyll content, and plant far from the PGC were having a smaller chlorophyll content. And now the the most interesting part is the flowering day too is actually affected by the proximity of the perennial ground cover. In the first year, as we did not see differences, but in the second year, we actually saw a lot of differences as plants close to the PGC were having, it took longer days for them to flower. The plants that are above 6 inches are comparable with the control plants, but plants that are very close, like the 6 inches, were actually showing higher, it took higher days for them to flower. I still don't have the yield data now, but when you follow up with our communication team, obviously when the yield data is out, I will make sure I give it to the communication team and they can channel it to you. But with our conclusions, the impact of perennial ground cover growth on our corn plants is very minimal in the first year. We normally don't see any differences. But in our second year, we can see that plants, as they get closer to the perennial ground cover, especially when they are close to about 6 inches from the perennial ground cover, their growth and development is seriously affected. And plants that are far from the perennial ground cover, as above 6 inches from the perennial ground cover, although their growth and development is affected, but mostly it doesn't impact their growth and development that much. And finally, we also didn't see the importance of applying the fertilizer, the starter fertilizer on the corn plants, because it didn't help the plants compete well with the perennial ground cover. Thank you.
Perfect. Thanks, Amina. Again, if anyone has questions, please feel free to type them in the chat as we go, and we can make sure to direct those towards our presenter. And if you would be so kind to fill out our poll questions, we do greatly appreciate your responses and try and tailor future presentations to sort of answer some of the questions and concerns that people have. Amina, I do have a couple questions for you as we switch over slides. So Erin, feel free to start sharing your screen. But one, your experiment was non-suppressed, right? You didn't suppress the ground cover in any way.
Yeah.
So clearly that's putting us in a worst case scenario, and we recommend suppression. But in order to understand how far away things need to be, I think your experiment really helps us answer that question. But could you talk just a little bit more about the difference between year 1 and year 2 in this study? Essentially, you planted corn on the same site, and the perennial ground cover in year 1 had just been established. Could you just comment a little, how vigorous did it look in year 1 as compared to year 2?
Actually, in the year 1, we actually tried to establish the perennial ground cover, but because we were not able to establish it on time, we used strips of Kentucky bluegrass in this case. And because we were actually trying to water the Kentucky bluegrass to enable it acclimatize to the weather conditions in the field, we still did not, like, it was more or less that we were favoring the crops closer to the perennial ground cover. So we did not see much differences in this case because the Kentucky bluegrass was not well established in the first year. But in the second year, we can actually see differences because we did not suppress it too. And we can see a lot of differences in that case.
Perfect. Thanks. So for the first year, you're saying maybe some of the competition between the grass and the corn was mitigated because you were doing some watering to help that, so you didn't see that close distance effect. But in year 2, it was really clear.
Yeah.
Okay. And then 2 asked a really difficult question, and I might ask Brent to try and comment on this as well. But based on what your experiment showed, what's our recommendation for current distance, and how confident are we in that? So I think based on what you had, you really broke up into 3 classes, and you saw that less than 6 inches away class was probably really too close. We need to be further away from 6 inches between where we plant and that ground cover. Is that fair?
Yeah, when you look at the data sets or the corn plants we harvested in the field, a lot of the plants that are 6 inches from the perennial ground cover there were fewer seeds, and some didn't even have seed in them. So I may think around, I'm just saying in my head for just looking at the corn ears, around 15, above 15 inches were actually doing better as compared to the control. But in this case, because I have not statistically analyzed the data set, I'm not confident to give her the answer yet, unless I analyze the yield data first.
And some of that distance effect might be mitigated by good suppression of that ground cover throughout the growing season. So again, the work you're doing is sort of a worst case scenario, trying to understand maybe throughout the growing season how proximity is having an impact. but certainly as Brent talked about, maintaining that crop zone and getting good suppression is extremely critical for long-term success. So I think in terms of a full recommendation to farmers to this experiment really helps us understand maybe where we need to be at planting, and understanding some of our suppression options and making sure they will work will help refine some of those suggestions that we need to make. So thanks, Amina, for your time, and we greatly appreciated your presentation. Our third speaker today is one of the topics that I'm extremely excited to learn more about. I feel like it's one of the areas that I have a lot of concerns and very few answers at times, because it's not an area that I think about enough. But ERIN from the University of Kentucky has been doing some work on sort of understanding what our weed control options are in these perennial ground cover systems. So certainly that's an important thing for us to know a little bit more about. So ERIN, look forward to you walking us through some of the work you're doing and providing us with some recommendations on how to manage these systems.
Okay, had to get myself off mute there. Can everyone see the right screen here?
Yes, you're on the perfect screen.
Okay, so I'm not sure how many answers I will be able to provide you with, Dan, and one of the themes I think I'll have is that there aren't necessarily any really easy answers that are going to work every place that you want to be implementing the ground cover, but I'll do my best to talk through some of the things that we are thinking about. And so again, I'm at the University of Kentucky. It's a little bit different than Iowa in most years, although this year we seem to have some Iowa cold with us this winter. And I'm going to be presenting some of the research that one of the graduate students on this project, KIERA SEARCY, has been working on. So a brief overview for what I will go through today, maybe, here we go. Just a few thoughts about like how much weed suppression potential you might actually expect in a system that's using a perennial ground cover. Some of the weed management options in systems that have that ground cover in it. And then lastly, talk mostly about some of the research that we are working on. So I think this is a really good topic to follow what Brent and Amina both presented in terms of thinking through the vigor of the ground cover, how close it gets to the crop and everything like that. As well as Brent mentioned the need to baby the ground cover in the first year. So we've been looking at some research on controlling weeds during the establishment phase of the ground cover to see whether or not that actually can improve the stand of the ground cover that results, and thus presumably the weed suppression that's going to happen in the next crop. And then also look at controlling weeds or managing weeds in corn that has a ground cover system in it without damaging that PGC. And then lastly, I'll just kind of provide some really basic concluding thoughts on best management practices for weeds with systems with this. So to get to that first point there about weed suppression potential from the PGC, as you can imagine, it's going to be variable, even within a field, how much you can expect. So when people ask how well is my ground cover going to be suppressing weeds, I'm going to say it kind of depends on how much ground cover you have present, how much of the ground it is actually covering, which might be two slightly different things, and then also how well that ground cover is suppressed. So if we're talking about like in our cash crop, corn or soybeans that has ground cover under it, that ground cover is going to be suppressing weeds by using resources. So taking away light in particular and occupying space that would otherwise be used by the weeds. And both of those things are true if the ground cover is green and actively growing, or if it's suppressed. So in theory, we don't, Brent showed this graphic, we don't want the ground cover to be taking up too much water and nutrients while it's growing underneath corn or soybeans, because that could potentially be taking it away from the crop. So we don't really want to rely on that mechanism for the weed suppression, but certainly intercepting light in the area between our corn rows and taking up space, and then also just providing like a physical barrier are some ways that this might be working. So if you look at the photo on the left here, you see 2 rows of corn along the edges there, and the ground cover clumps that are in there are nice and vigorous, taking up a lot of space, but like the whole area between there is still a lot of open soil in there, or bare soil in there. So I would probably in here, like we might have really great weed suppression in that thin strip where the grass is nice and vigorous, but not in those other areas. So hopefully our grass, we've done a better job with the things that both Brent and Amina were talking about, managing our corn zone there. So we might be looking more at something like the photo on the left here, where we do have grass growing in between the corn rows. This is not super vigorous, and it's been well suppressed. So probably not a lot of weed suppression happening there. And you can see some annual grasses and weeds popping up between the rows. But as it starts to get more vigorous, less suppressed, you see fewer and fewer weeds resulting there. So again, just depending on how much area the ground cover is taking up. And then lastly, like not all weeds, unfortunately, are created equal. So a lot of the weeds like perennials, some of the larger seeded broadleaves, annual grasses are probably going to be better able to withstand these ground covers and not be suppressed as well. So weeds that we would expect to be suppressed by the ground cover include some of the small seeded broadleaf species. And good thing for us is that does include some of our really problematic weeds like Palmer amaranth and water hemp. Those are things that just don't do well when they're kind of crowded out and they need a lot of light to get going. So just a couple other things in our research that we've seen to just kind of bring up as things to keep an eye out for. We often have winter weeds that might be coming up as the grass is emerging or while the grass is kind of coming out of dormancy in the fall. And so they might be surviving the suppression application in the spring. So I have a nice looking field pansy in this example that came up the fall that we planted the grass. And then it's just not well managed with the herbicides we're spraying to suppress glufosinate. It's not resistant, it's just not an herbicide that works well on that species. So in that case, like now we've got this huge field pansy growing right next to our corn. And then this is probably more what we're thinking about for this talk when we're thinking about weed suppression from the ground cover. Here we've got a relatively thin stand of the ground cover, lots of bare ground around there, no residual herbicides used in here. As we're starting to see annual grasses and some broadleaf weed species move in. So assuming we do have these weeds in our corn, we do have limited herbicide options to manage those that are not also going to kill the PGC. So maybe the simple answer for this is if we do have a grass ground cover, like we have Kentucky bluegrass in this photo, we do have a variety of herbicides that we can use to target broadleaf weeds while not killing the grass. So that is something that we have working to our advantage. But once you get beyond that, it does, as Dan has mentioned, become a lot more complicated. So a lot of our go-to herbicides that we would be applying to control the weeds in the photo on the right here, that would take out both the annual grasses and those broadleaves, are more of our broad spectrum herbicides like glyphosate. That's also a systemic herbicide, which means it gets taken up by the plant, kind of moves throughout and kills the plant from within, essentially. So unless the ground cover is completely dormant or suppressed, it's a little risky to be applying these herbicides. There's a lot of potential for damage if there is still green tissue on that grass, because it can get taken up through there and move throughout the plant. So this leaves us with kind of the unsatisfying answer of we don't really have super great options. We do have some, but we want to be really careful about over-relying on those so that we don't develop resistance issues. Now we have some experiments planned to be looking at the use of some of these other herbicides that might be an option. But again, it's a complicated topic to study. And on my next slide, just going through some thoughts about this. So like, what can you actually apply to manage weeds, but not kill the grasses that are might be in your field or the perennial ground cover? So as you start to think through this, first of all, thinking about what types of weeds are present. Not all herbicides are going to work effectively on all species of weeds. And so the label and the extension guidelines in your area will help you figure out if it's even something that's going to be managing the weeds that you have. Certainly taking resistance into account as well, which we know is quite problematic no matter where you are these days. And yeah, so this is a question that we know a lot about, targeting specific weeds with herbicides that can be used widely across the United States. But we do know a lot less about how those are potentially going to affect the ground cover. One of the reasons I think that this research gets pretty difficult is that the potential for damage on these ground covers can be influenced by a lot of things, in particular, the vigor of the ground cover, how healthy it is, and the weather too. Both of those things are going to influence the potential for damage. And so, unfortunately, Dan, this is getting to your point of lots of questions, not a whole lot of really solid, concrete answers on what can be sprayed. And I think there is a little bit of other guidance out there. We're starting to be able to roll this out on a wider area of different products that we can apply. Again, with the caveat of like, we don't want to become over reliant on just one or two things in these fields. So with that, punting, Dan, sorry, I was going to switch gears and talk about some of the research projects that we're doing and just kind of our approach for this to try to learn, like the types of things that we're doing to try to learn about whether or not we can be targeting weeds without damaging the ground cover. I'm seeing a couple nodding heads, so okay. So I'm gonna jump into talking about two of the research projects. The first one is looking at how herbicide treatments might be helping. We work with Kentucky bluegrass in Kentucky, might be helping the establishment of that ground cover. And so our hypothesis behind this, or kind of the overall thinking on this, is that if we can manage weeds better when we're getting that ground cover established, as Brent mentioned, it's a small seedling, it's slow to get going. Will that result in a better and more vigorous growing stand of the ground cover into our next cash crop year, and thus better suppression of weeds in the next crop? So that's kind of the idea behind this experiment. We're looking at different herbicide treatments applied to the grass in both the fall and the spring. We're looking at pre-emergent herbicides that get applied soon or right after the grass gets planted, and then also some post-emergence applications in the spring and or in the fall. And that's the last I'm going to say about the post-emergence ones, because we didn't actually see that many impacts of that on the grass or on the weeds, interestingly. So I'm going to focus mostly on these pre-emergent ones applied. The photo you're looking at just shows a couple of our treatments, a matrix of one of the herbicides applied at planting on the top, and then kind of our control treatment with no herbicide applied at the bottom. And then the photo on the left is the grass in the fall, so about a month after planting, and the ones on the right are the following spring. And I do need to mention, I don't think I wrote this on the slide anywhere, but we did irrigate our grass. We basically had no rainfall in the fall that we did this experiment for, I think, about 5 weeks. And when you have graduate students that are working in your program for a limited period of time, they need grass.
That's always scary when you lose your speaker for a moment or two. So hopefully Erin will be back here in just a second. But I'm sure what she was going to say is when you have graduate students that need to graduate, it is important to make sure that their research can move forward. And that's why they chose to irrigate. Although it is always amusing to me that Kentucky had to irrigate to grow Kentucky bluegrass. While we're at a little bit of a standstill here, how about we try and answer some of the questions that we got moving while Erin logs back in, hopefully, for us to finish this off. So one of the questions we got, and I'm going to direct this one to Brent. It was a great question. They missed last week's webinar. Corn versus soybeans, what rotations are we growing these in? And what are some of the differences that we have to try and manage when thinking about corn and soybean systems?
So the on-farm cooperators all of them are corn soy rotations. So depending on how long they've been around, depends on obviously the crop that they're planting. So we do have some field experience with soybeans. In relation to crop zone width, obviously we're flying without data that AMINA had shared with us on corn. but it does appear that soybeans seem to be a little more tolerant to that early season competition to a point. I mean, we can't let the sod come into that soybean row as well. So we still need to maintain a crop zone, but I think our experience with cereal rye as a cover crop and people planting green into, standing cereal rye with soybeans and having good success, I think is another indicator that, soybeans do seem to be a little more tolerant to that early season competition, but yet my view and my suggestion would still be let's try and get a crop zone developed there, particularly for in a rotation. So because we're going to be into corn, the next season, so we don't have to go in and do some serious cleanup of what might have happened during the soybean year. So my suggestion is 15-inch band for each crop.
Perfect. And that really does mean we're advocating for 30-inch soybean rows.
This is fair. There are some questions from crop owners is, can I plant 15-inch and just see what happens? And planting soybeans into a perennial cover is a struggle. So it does kind of point to the need for having that crop zone.
Yeah. And I will admit, I planted some RHB and drilled in soybeans to it this first year and had great success. But it was spring planted for both, and I wasn't really fighting much of that sod effect. Do you have any recommendations for that first year? Should we be trying to establish our perennial ground cover before corn, before soybeans? Is there any difference between those two options?
Probably it comes back to, and I hope Erin can rejoin us, because I think it's probably that herbicide question is, since we can't use a lot of our typical herbicide programs in our corn system when we're in that establishment year, I'm wondering if soybeans actually might give us a little more flexibility in that being able to tolerate that. Some of the herbicide packages that we could use in soybeans tend to be a little, once you pull the glyphosate out, tend to be a little more forgiving on grasses than others. But that's a little bit speculation on my part. I think the biggest thing for establishment, and Erin pointed it out, is that dry weather's a killer. We were trying to get establishment in the fall. We had 3 years of dry falls and really struggled to get the stands. Last year, some guys tried seeding in early spring, like March, and had great success because we got moisture. So I think it's that if you're so good that you can figure out when the moisture is going to come, that would be preferred versus fall or spring.
And that's why I actually ended up planting my RHB grass in the spring. Is I said it's going to be wet and at least it'll grow. And then I learned a few lessons from that it doesn't green up or it doesn't go dormant nearly as early when you plant in the spring. But I still had some good luck with that, with soybean, not so much with corn. So Erin's back and ready to continue your presentation. So we'll go back to that, and then we'll get some more questions here at the end.
Yeah, sorry about that. We're having like construction all around our building, and sometimes our internet just disappears, which is really cool. So anyway, I'll just sum this up now. We'll just like pick up where we left off. So basically, like, yes, we can apply some herbicides when we are planting the grass. We can reduce the amount of weeds, increase the grass biomass. Doesn't always lead to supporting our hypothesis that we'll have more grass growing through the next corn growing season and better weed control in that corn. Now, I do want to issue a very important caveat that we, in addition to having no rain in the fall that we established that experiment, we had an incredibly warm winter that year. So if you're thinking about a cool season grass, it was like great cool season grass growing weather. So it was probably going to be different this year when we've been very cold and more stressful for the grass. Just a quick thing, that the treatment that had the most successful weed control, which was applying mesotrione at planting of the grass, it had visually the most bluegrass too, although a lot of variability in that. It also had the lowest corn yield, and so that really highlights the importance of good suppression of this ground cover as you get into the next cash crop. So let me just introduce quickly the next experiment that we did, which is, I think, getting to some of the major questions here about what can we apply to our corn while we have PGC growing. I came back in when Brent was talking about soybeans too, and but this trial was focused on corn. So we tried to find some herbicides that we could use to manage the weeds in the corn but not harm the bluegrass. We used one premix herbicide that had 3 different actives in it. So this is one of the newer products that provides really great weed control throughout the growing season. We sprayed each one of these actives individually. We also had a treatment with no pre-emergent at all, just to look at the impact solely of the grass, and then a treatment with glyphosate to hopefully be able to kill out the grass. So what did we find in that? I'm going to show you the number of weeds that we had present when we harvested the corn the following fall. So this is the number per square meter, so it's about a square yard. So we had, and then the different treatments that we applied at corn planting here on our x-axis. So here's our premix that had 3 active ingredients, each one of them individually, and then the one with no weed control in it other than what the grass was providing. Some of the plots got a post-emergence herbicide. Sorry, that's the one shown in brown. That was applied at V5, and then some of them did not get a post. So the green bars are like just what was applied at planting. So some of the pre-treatments, the residuals were more effective than others, and were able to keep weeds down throughout most of the growing season, especially this premix that has 3 different ones in it. And we know this from years of doing herbicide research. Some of these are quite effective. If you're not going to use a pre-emergent herbicide, the post-emergence herbicide was really needed to be able to reduce that weed density. So this right here, this green bar is like if you have ground cover in your field and you are not applying a pre-emergent herbicide. How much weed suppression can you expect? You still have quite a few, you're going to have quite a few weeds in there, at least in our experiment. So if you're going to be using Kentucky bluegrass as your ground cover, having a pre-emergent will really help you reduce the number of weeds that you're going to have in the field, and or using a timely post-emergence treatment. Our post-emergence treatment is a combination, also has about 4 different active ingredients in it, from the group 2s, which are ALS inhibitors, and group 15s, which are the HPPD inhibitors, is group 27. And again, remember that this is kind of specific to our climate, the weeds that we had in our field, so your results might vary. Now to the main question about whether or not these treatments affected the corn biomass, the grass biomass. The short answer was no. The pre-emergent treatments had similar grass biomass at corn harvest to not spraying one of the pre-emergent treatments. Interestingly, what did increase the grass biomass was applying a post-emergence treatment. So if you're able to come through and clean up any weeds that were present, you had slightly higher grass biomass on average than if you didn't, about 20–25% more. And that's likely because you're reducing that weedy competition that's in there. So this is kind of what we're getting at with some of our research. And I think one of the questions that's coming out is like, again, what can we spray to help manage the weeds in the corn, but not be harming that grass that's in there? So some pre's are going to be more effective than others in reducing weeds. Again, this is just something we know from years and decades of doing herbicide research. Our 1 year of data suggests that maybe we didn't need that post if we were able to choose the right pre-emergence treatment. But again, those are highly dependent on weather. And we were very dry throughout most of 2024. So again, we need a lot more research on this type of topic to be able to figure out better recommendations for this. And if you're not going to use a pre-emergence treatment, be prepared to spray something post-emergence to manage the weeds. What that post-emergence application is going to be, again, is going to depend on what types of weeds are out there. And we need a few more site years of research, I think, to be able to make recommendations on things that are not going to be damaging our grass. So in terms of best management practices, these are things that we would always hope are going to be part of the equation, but starting in fields with low weed pressure, especially as we're rolling out new and management intensive things like this ground cover, especially for weeds that are going to be harder to manage with herbicides like these annual grasses and perennials. The use of soil residual herbicides can really reduce weed emergence and reduce the number that we do have to manage without killing the grass. And then practicing good scouting to find areas where we don't have as much ground cover and we might have these weed escapes, and dealing with them before the end of the season when they're going to be producing seed and creating problems in future years are some good general best management practices. So with that, sorry about the snafu, and I will thank a number of people that have assisted with this research. And Dan, I'll stop sharing.
As we get back into the swing of things, Erin, I have a question for you. As you think about the ability of the ground cover and its potential for weed suppression, what is that potential of the ground cover to suppress weeds? Is that something that we think we can realistically achieve? And then as we think about both those pre and post-emergent herbicide passes, which one are we talking about cutting or reducing? And then in your view, how much ground cover is necessary to achieve the level of weed suppression where we might think about getting rid of one of those passes? And is this a realistic possibility in the future or still a long ways off?
I will say, especially from an herbicide resistance management point of view, yes, it would be fabulous if we didn't have to rely on pre-emergent herbicides, but I would rather rely on a pre-emergent herbicide when things are a little bit more predictable than relying on post-emergence later in the growing season when all sorts of things can happen to delay that, make it not feasible, etc. So while I like the idea of being able to reduce that, I would rather see some of the other potential herbicide passes reduced rather than the pre-emergent. I think, especially in terms of managing resistance, that's a really powerful tool that we have right now.
I'll jump in here. I would strongly agree with Erin's comments in that we need the pre, because think about it. If we do have a successful crop zone, you have an area early in the season that does not have cover, that is going to grow weeds if there's not some type of other mechanism to suppress that herbicide. And since we don't want our ground cover that close to our corn or soybean plants, we still need to have a pre-emergence program factored into this system. Now we'll learn in time what happens later in the season, but strongly agree at pre-emergence, you want to have a clean field to start this system out with.
Agreed.
All right, a couple housekeeping items, and then we'll get back to some more of the questions. So one of our questions this time was related to other grasses, specifically maybe bulbosas and radix hybrid bulbosa. Next week, we're really going to focus in on that. I think a lot of the experimental work this time focused on bluegrass, but we have had quite a few trials trying out this radix hybrid bulbosa. So Dr. Fay, Patrick, Jack, and Brandon will be talking about some of their experiences, both with multitudes of types of grasses, improving establishment, and then some on-farm trials again. But if you are interested in hearing more about other grass options, tune in next week and we'll really focus in on that portion of the system. If you were not present last week or didn't, don't click, or would be willing to fill out our demographic survey, if you scan that QR code, it will take you to a survey. USDA, who is funding this grant, asked that we try and fill out the voluntary demographic survey. So if you've already done it for this webinar series, you don't need to do it again. But if you haven't yet done so, we would appreciate you filling out that demographic survey. So I'll give everyone just a moment. If you are seeking Certified Crop Advisor continuing education credits, you can get those if you watch this webinar live. Just send the information to Melissa McAnany, MMCENANY @iastate.edu by the end of the day today. So by 5 p.m. What you need to include in that email is your name, the name you used to watch the webinar, if it's different than your name, and your CCA number, and she will help out with that paperwork. So if you're interested in CCA credits, just make sure you send that information to Melissa. Iowa Learning Farms has a webinar tomorrow at noon. So almost same bat time, same bat channel, just a day later. And they have Andrew Rust from the Nature Conservancy, and he's going to be talking about some oxbows and what they've been doing on some Iowa streams with oxbows. So very much a water quality seminar, but hopefully of interest to some of you. And then we do archive things. So if you have someone who might want to be informed about perennial ground covers, you can find today's webinar and other RegenPGC videos on our YouTube channel, which is at RegenPGC, or the presentations and field notes can be found on our regenpgc.org website with links to the handouts. So that takes us through our bookkeeping. I need to stop sharing. And then looking back at some of the questions. Brent, Erin, or Amina, have any of you tried any RHB and have a feeling for how it might differ for some of your experiments compared to Kentucky bluegrass?
We do have one cooperator who has a very small area of the Radex hybrid bulbosa, which is Poa bulbosa. It was seeded last spring early, so we're in that first year. So all my comments are very, very preliminary. The one thing that I did notice is that it does go dormant very soon in the season, which was it is different than Kentucky bluegrass. So I guess I'm hopeful that that will improve our odds of being able to manage the suppression aspects of perennial ground covers by switching to a different species of grass.
Perfect. And Erin hasn't tried it out yet, so not as much information on spraying it, or at least how it's interacting with some of these chemicals.
In my research, I only use Kentucky bluegrass. I didn't use Poa bulbosa.
Mm-hmm. All right, so as of yet, we don't have as much information on POA. It has been, as Brent alluded to, an emerging option for all of us. I think as we started this trial, we had more experience with Kentucky bluegrass, and that was where much of the focus had been. But as we've been moving forward, we've seen a lot more interest in that Radex hybrid bulbosa. So if you have any last questions, now's the time to put them into the chat. Otherwise, I would like to thank everyone for joining us today. It was a great conversation, and hopefully you learned a fair amount. I know I learned a lot from it. So thanks again for joining us. Hopefully you'll be back next week to learn some more about some of those ground cover options. Otherwise, thank you to Brent, Erin, and Amina. It was great to see some of the research and some of the work that you all are doing.